Welcome back to theCUBE. We're here at Hadoop Summit in San Jose. Beautiful sunny San Jose, as far as I know. It was nice this morning. I haven't been outside in a while, but
we're still very nice.
Yes, I've got my co-host, Abi Mehta, filling in
Thank you.
from Tresata.
A guest co-host?
A guest co-host. You know, we're trying new things on theCUBE all the time. And our guest now is Chris Mattman from the Jet Propulsion Laboratory at NASA. Very interesting stuff.
Nice to meet you guys.
Nice to meet you. Welcome to theCUBE. It's a painless environment, no worries at all. So,
you haven't hurt me yet. So,
so you were just coming from a talk you gave.
Yeah, I was just coming from talk.
Why don't we share a little bit with our audience kind of what you were talking about, and then maybe we can go into some of the use cases, things you're doing at NASA.
Yeah, no problem. Yeah, so I basically was talking about some of the challenges, like some of our big data scenarios that we have at NASA, like for example, the Square Kilometer Array, which is an international project, the next generation radio astronomy instrument that's going to generate about 700 terabytes of data per second.
Oh my God.
Which we really don't understand.
Say that again, 700 terabytes per second?
Yep, per second.
So that's 15 times more than the Large Hadron Collider.
Yeah, and your math is better than mine, so, because you came up with that on the fly. Yeah, absolutely, it's the largest. I mean, we don't know how to even deal with that. There's got to be a decades of research to support that. So I was talking about projects like that, the U.S. National Climate Assessment, a lot of the work that we're doing related to that, and just trying to motivate the development of technologies and the use of technologies like Hadoop and other things. So
can you talk about, and Jeff knows this, we've seen Hadoop come from the web, this cottage industry project 6 years ago, 2,000 people behind us now saying no longer cottage industry, this is a real industry. How does it change the game for you? You have a lot of, what were you doing before? And what can you do now that you could never do?
Yeah, so I mean, what we were doing before, well, what I was doing was helping be one of the guys that helped make Hadoop. I was one of the original nudge committers working with Doug Cutting.
Okay.
Yeah, in the open source world.
Well, thank you for it.
Before Hadoop got spun out. But yeah, what we were doing before was basically building ad hoc systems, having people haul a lot of data around, crunch on it locally, instead of doing it in kind of a distributed environment and stuff. Hadoop, I think, originally, it was very difficult to use and install, but was awesome. Only like the smartest people in the world could use it.
Yeah.
I think Hadoop is really moving into a generation where a lot of people can deploy it. People are getting a lot of value and data and just insight out of it. And just anybody in the organization is being able to do that. And then that's got to be where Hadoop evolves to. And it's something I think it's awesome,
So, obviously NASA has a rich heritage of, in the technology world, developing technologies and that eventually kind of make their way out into the wider world. So, talk a little bit about some of the experiences you've had and how they would relate to some of our audience who maybe, they're not at NASA, they're at, a little less sophisticated organization.
Exciting job, yeah.
You guys are giving us too much credit. No, for us, I bet you it's pretty similar even to business or to, other IT industries. For us, it's just different data file formats and it's different things that are generating the data. A lot of people or a lot of companies like Yahoo or whatever, the data is being generated by users, like hundreds of millions of users that do clicks or whatever. But you can think of that in a way as something that is being observed and then some derived analysis that happens from that. For us, the thing that's doing the observing a lot of times, at least at JPL and at NASA, are our remote sensing instruments that look at the Earth, that try and measure different parameters. They're looking at surface albedo, reflectance, and they're looking at the measurement of snow in a particular pixel of the Earth, and then it's basically the things that are different are the data file formats, the tools that operate on them. A lot of people here in the Hadoop community are, they're R users, they're Python users. We're not as sophisticated a lot within, NASA, because a lot of the people that write our algorithms and our codes to crunch on the data, they're scientists that aren't trained programmers. They pick up a little bit of programming, along the way. And so those are the main sort of differences. The differences are in kind of the variety, the velocity, the typical big data, things, but also just in the nuts and bolts. But in the end, it's the same thing. It's generating data, generating, in our case, files or records, processing them, getting some insight. Our insight go into policymakers, they go into science research, they go into monetary decisions and things like that. But
the team at, I have a related question for you. The team at Wikibon and SiliconANGLE have done a great job, and CUBE. We see that the emergence of what we're calling this predictive analytics movement, that it's not about what has happened, but being able to predict what can happen, what can you do and predict the data. As I'm assuming you at NASA with all the information do a lot of predictive analytics, but to the point you just made around, it's tough to find the skill set. Scientists are not programmers or vice versa, at least not always.
Right.
a corollary to that is the open data movement.
Right.
Which is as you're collecting 700 terabytes a second, I still can't get it over my head. 700 terabytes a second of information. Are you looking at open sourcing the data itself and inviting the smartest brains from the world to contribute to the intelligence you're seeking to find in that data?
I think so.
What do you think? Okay.
I think so. I mean, NASA's data technically is all of NASA's data is public. It's science research data. So all of the data produced by NASA, Earth science missions, by Planetary, it's all eventually made public. For us, when it's not public, typically it's because it's, it's protected ITAR information, or it's just something that people wouldn't be able to crunch out in the open anyways. But all of NASA's science research data is public. The difficulty what we see is that a lot of that data is specific to the instrument. You have to understand a lot, about it. But as far as the data sets, all of the time people pick up NASA data and they figure out how to crunch on that. It's just not, I don't know, I can't explain why people haven't just picked it all up, and said, oh, let's put all this onto Amazon and start dealing with it. But a lot of it has to do with politics and so forth, and also just making sure the data stays where it was originally generated, because a lot of the science expertise is there.
Okay, interesting.
Yep.
So for us laymen, could you maybe give us a couple of examples of where big data analytics has really had an impact? Kind of give us the end result. What are some of the insights maybe you've gleaned, or some of the analytics you've done that are really a lay person, a non-NASA person could actually understand?
Sure. So I'll give you one example by a guy named Dr. Tom Painter, who is one of my inspirations at JPL. He's a snow hydrologist. Basically, what he's working with the Bureau of Reclamation. He's working with the water managers in the Western U.S. and he's trying to figure out how to generate more accurate measurements of snowmelt and snowpack, so that we can get better measurements of water, so that we understand, that water managers understand how much water to release for the coming season, or just people know what to predict in terms of recreation and parks. Like parks and recreation is a $10 million industry, in Colorado and the Western U.S., just people going and skiing and things like that. And so if we don't have snow around, people can't do that. And a lot of people that are in the money-making profit stream for that, hurt. So being able to generate more accurate measurements of snow and being able to use data systems and big data and analytics for that is just something where I think we're seeing a lot of value on. It's contributing to the U.S. National Climate Assessment. It's going into all of the climate reports and so forth. So that's something that's really fresh on our minds.
So you think, to be a little bold, that big data can help solve global warming? It's a big data problem?
I absolutely think it's a big data problem, and I will be bold, and I think it can do that. Yeah, I think basically most of the work, for running climate models is, shipping data around, shipping computation around, all of the types of things, and then making, like you said, your predictive analytics was really great, because a lot of NASA research is retrospective, trying to learn a model from what has already existed. And people are kind of gun-shy to make predictions a lot of times, because especially when they deal with policy and money and things like that. But I think, I'll just make a statement, I think that that's a big data problem, and that's what we need to get there.
Absolutely, yeah. I think the predictive analytics is really where, is really the next step, rather than just looking back, and you know this as well as anybody, Abhi. So, all right, great. Well, thanks so much, Chris, for coming on. Really appreciate it.
Thanks, guys.
Inside theCUBE. We will be right back in a moment with our next guest.